Which graph shows a function whose derivative is always positive? Well, let's actually try to figure that out. We can approach this both algebraically and graphically. Let's first start out with the algebraic approach. Answer choice A is a parabola, and it passes through the origin. So its equation could be considered y equals a times x squared. And a has to be a positive number in this case. Well, if we take the derivative of this, it's going to be equal to 2 times a times x. And since your x values could be negative or positive that you would substitute in here, you could get both negative and positive outcomes here. So y prime could be positive or negative. Depending on the location of the point. So therefore, answer A is definitely not always positive. Let's look at answer choice B. It's a linear function that has a negative slope. So y is equal to negative a times x. Well, y prime in this case will be negative a, and a is any positive rational number. So therefore, y prime will always be negative. So that rules out answer choice B. If we look at answer choice C, we have a cubic. So we can write this one as y equals a times x to the third, and a is positive. And I should put a is greater than 0 in this one, as well as this last one. A is greater than 0, but because of this negative here, it will always be a negative value as that final output. All right, so then if we differentiate, we're back at choice C and we differentiate it, y prime will be equal to 3a times x squared. Now some may think, well, if I put negative 1 in here, it's going to be a positive. If I put negative 2 in here, it's going to be a positive. If I put positive 3 in here, it'll be positive. So we might think that C is the potential answer here. However, if you put 0 in there, y prime of 0 will equal 3 times a times 0 squared, which is going to be 0. And 0 is neither positive nor negative. So therefore, this one cannot be always positive. So answer choice C is ruled out. If we look at our final answer choice of D, we have originally y is equal to a times x, where a is greater than 0. Y prime will be equal to a. And since a is greater than 0, it has that positive slope, y prime will always be positive, which makes it the correct answer. You could also approach this graphically. The derivative tells us the slope of the tangent lines. So in part A, I can have a tangent line that's negative. I can have a tangent line that's 0. I can have a tangent line that's positive here. So that's another way to prove that A is not correct. B is not correct because all of these tangent lines will be negative. We would be drawing more negative slope lines on this current line. So it's always negative. In answer choice C, the slope of the tangent line can be positive, both down here and up here. But then at 0, the tangent line is, or has a slope of 0, which is neither positive nor negative. So that's again why C is ruled out. And D, all of our tangent lines will lie along this line and they will always be positive. That is why D is the correct answer for this problem.